Modern security depends on controlling secrets wherever privileged access, applications, pipelines, and cloud services intersect. In this module, we'll compare Azure Key Vault and HashiCorp Vault, then connect them to PAM, automation, dynamic credentials, and practical enterprise design choices. We've built the privilege story from the ground up: identity basics, PAM controls, Microsoft PIM, enterprise platforms, and privileged access across operating systems, cloud, and Kubernetes. Now we'll focus on secrets, how applications and teams protect, retrieve, rotate, and audit them before we design a complete enterprise PAM program. Secrets are more than passwords. They include API keys, tokens, certificates, SSH keys, encryption keys, and credentials used by applications, pipelines, cloud services, and infrastructure. In PAM, every secret is a privileged access artifact because it can unlock systems, data, or administrative actions. In DevOps, the risk increases when secrets are copied into code, scripts, build logs, spreadsheets, or CI/CD variables. Strong secrets management centralizes control, enforces least privilege, supports rotation and short-lived access, and records usage. That is why modern PAM must cover humans, machines, workloads, and automation together. Azure Key Vault acts as the controlled handoff point between sensitive material and the workloads that need it. Secrets include values like passwords, API tokens, and connection strings. Keys are cryptographic assets used for encryption, signing, or wrapping other keys, with options for HSM protection. Certificates support TLS and SSL identity, including import, renewal, and lifecycle tracking. The value is not just secure storage. Key Vault integrates with Azure Identity, RBAC, monitoring, and automation, so access can be governed, audited, and rotated consistently across services and applications. Access to Key Vault should begin with identity, not embedded passwords or connection strings. An Azure app, function, VM, or container can use a managed identity to request a token from Microsoft Entra ID. Key Vault then checks authorization before releasing a secret, key, or certificate. For new designs, Azure RBAC is usually preferred because permissions are managed centrally and scoped consistently. Access policies still exist, but they operate through the Vault's access policy model. The PAM principle is separation. Administrators manage the Vault, while workloads consume only the specific secrets they need. Operational security for Key Vault starts by assuming mistakes and abuse can happen, then making both visible and recoverable. Use diagnostic logging to capture access attempts, administrative operations, and denied requests. Then send those events to Azure Monitor, Log Analytics, Sentinel, or your SEMI. Enable soft delete so removed vaults, keys, secrets, and certificates can be restored during the retention window. Add purge protection to prevent permanent deletion until that window expires. Finally, reduce exposure with private endpoints, firewall rules, and trusted service restrictions. Together, these controls support detection, recovery, risk reduction, and compliance evidence. Rotation is not just changing a password on a schedule. It is a lifecycle discipline. A credential is created, stored in Key Vault, granted to the right identities, used by applications, and rotated before its lifetime becomes a liability. Secrets often need outside automation, such as functions or CI/CD pipelines. Keys can use versioning so encryption services move safely to newer versions. Certificates add issuance, renewal, expiry alerts, and CA integration. The critical design point is consumer behavior. Applications must fetch or refresh values safely, so rotation improves security without causing downtime. HashiCorp Vault serves as a controlled gateway between anything that needs a secret and the systems that can provide it. Clients authenticate through an identity-based method, and Vault evaluates policy before allowing access. The real capability comes from secret engines. KV stores static secrets. Database and cloud engines generate short-lived credentials. PKI and SSH issue certificates. Kubernetes supports cluster workflows, and Transit provides encryption as a service without exposing keys. Vault also depends on secure storage, audit logging, initialization, unsealing, and disciplined operations, so the model can scale across data centers, clouds, and automation pipelines. Authentication in Vault is the gate between a caller and a usable token. Different callers prove identity in different ways. A person might use OIDC, LDAP, or UserPass. An application might use app role or certificates. Cloud workloads can use IAM-based methods, and Kubernetes pods use the Kubernetes auth method. Vault maps that verified identity to policies. The token is not the permission by itself. It carries the policies that define allowed secrets, operations, and APIs. Strong designs favor short-lived tokens, strong identity binding, and least privilege mappings, especially for automation. Vault authorization is built from three connected ideas: policies, tokens, and leases. Policies define what a caller may do and where, such as read access under secret, data, app, one of Starix, but no delete or sudo elsewhere. A token is the credential that carries those policies after authentication, and it has a lifetime, so access is not permanent. Some tokens can renew, some are short-lived, and batch tokens are optimized for high-volume use. Leases apply to dynamic secrets, such as generated database credentials. When a lease expires or is revoked, Vault can invalidate that credential and reduce the damage window. Dynamic secrets are where Vault becomes especially practical. Instead of storing one shared database password or cloud key, an application authenticates to Vault and receives a credential created for that request. Vault can create a temporary database user, issue short-lived cloud access, grant SSH access, or generate a certificate through PKI. Each secret has a lease, so it expires or can be revoked automatically. The result is just-in-time access, least privilege, and far less credential reuse. In enterprise environments, Vault becomes both a control point and an evidence source. Every request can be written to an audit device, capturing who authenticated, which path was accessed, what operation occurred, and useful metadata while masking sensitive values. Those events become most valuable when forwarded into monitoring and SIM tools, where teams can detect unusual reads, token creation, lease revocation, or policy changes. Vault also needs to fit the surrounding ecosystem: Kubernetes, Terraform, Cloud IAM, CI/CD, and applications. Production success depends on operations as well, including high availability, backups, recovery, sealing strategy, and clear runbooks. A good mental model is to treat secrets management as a broker, not a storage drawer. Applications should prove who they are with a managed or workload identity, then receive only the specific secret they need. For databases, avoid shared accounts by issuing temporary credentials with narrow permissions and a short time to live. For pipelines, retrieve secrets just in time, keep them out of logs, and revoke access when the job ends. In cloud environments, prefer workload identity over stored keys. Across these patterns, the goal is the same: least privilege, short-lived access, no static secrets, and clear auditability. Choosing between these tools is less about which one is better and more about where each one fits. Azure Key Vault is a strong choice for Azure native workloads where you want managed operations, RBAC, managed identities, certificates, keys, and tight platform integration. HashiCorp Vault is stronger when secrets span clouds, Kubernetes clusters, on-prem systems, databases, and automation pipelines, especially when dynamic credentials matter. In many enterprises, the best answer is both: Key Vault for Azure services, Vault for cross-platform secrets, with shared governance, audit, and policy standards. Modern PAM must protect more than administrator accounts. Applications, pipelines, cloud workloads, Kubernetes, and automation all need governed secrets. Azure Key Vault provides Azure native controls for identities, keys, certificates, logging, recovery, and rotation. HashiCorp Vault adds broad platform support, dynamic secrets, leases, policies, and auditing. Next, you'll combine these building blocks into a complete enterprise PAM program design.